What is training volume and why should we care? In this video, I'm going to go over the many ways you can quantify what you do in the gym and why most people in the industry use number of hard sets. Let's dig in. So we know what volume is from a geometry standpoint, the amount of space something takes up. Lifting volume, for many folks I see in the gym, works similarly. They go in and just keep lifting heavy stuff until the void they feel from past trauma has been adequately filled. That's a fine way to go about doing things, but perhaps not the best. In order for a quantification tool to be useful for us, we have to be able to measure it, and there needs to be some sort of dose-response relationship, meaning as you do more, you get more in return, at least up to a point. For example, our internal void is as of yet unmeasurable, so it's hard to quantify a dose-response relationship. And even if we could, it probably doesn't correlate well enough with gains for it to be useful. So it fails on both of these fronts. Now let's take a look at some more serious ways to quantify volume and see if they stand up to these two minimum criteria: ability to be measured and some sort of relatively consistent dose-response relationship. Let's start with reps. Reps in the gym can definitely be measured, but unfortunately, there isn't a consistent dose-response relationship. A set of 5 to failure produces similar gains to a set of 25 to failure. So if we were just counting reps, we would run into a lot of problems. This, by the way, will be covered in a couple of videos. So while reps can easily be tracked, they don't have a useful dose-response relationship. What about volume load? Sets times reps times load. It can definitely be measured, but what about the dose response? Well, it's the same issue as counting reps. Even though it's quantifiable, there isn't a clear dose-response relationship because the metric is very sensitive to changes that do not affect hypertrophy outcomes. For example, someone can easily bench press 235 for 5, but can also bench press 185 for 12. Even though the volume load for 185 for 12 is higher, they both produce similar amounts of hypertrophy. What about time under tension? That's a popular one. Well, this runs into the same issue. A higher rep set will be a lot more time. Slower reps will also add more time, but both of these don't necessarily add more stimulus. Don't worry, again, each of these will be covered in a later video, but you could see, just based on logic, how you run into many issues when just quantifying the time under tension. There's tons of things that can change within a set that increases the amount of time, which unfortunately doesn't correlate with the amount of anabolic stimulus or growth. What about effective reps? This quantification tool was popularized around the thought that the last 5 reps of a set are the ones that cause the most growth, because that is when the set gets hard enough, and so our bigger, more growth-prone type 2 or fast twitch muscle fibers are getting activated, and the reps are slow enough so that there's enough actin and myosin interaction in our muscles to get a good growth stimulus. The problem with this model is not the physiology. It is that it's basically saying that there would be no growth from more than 5 reps away from failure, which is definitely not categorically true, and it also assumes that all of the last 5 reps are equally growth promoting. They're all counted as one, which is currently unknown and perhaps very unlikely in all contexts through a session. You also probably want to know how many sets an individual is doing and how close they are to failure. And if you are doing that, you already have all the information that would be had if you wanted to count these so-called effective reps. So at the very best, it is redundant with information you would already know and take into consideration. At the very worst, a person may come away thinking a set with 5 reps in reserve has no hypertrophy stimulus or 0 effective reps. But what about a true effective rep number? Can't we use that? Well, that could be a useful model if we had any decent grasp of what that number would look like in different contexts. But unfortunately, we don't. We are not even close to that, so trying to put an effective rep number on every set would give us a false sense of certainty, and using 5 for every set is relatively arbitrary and very likely simply incorrect. Would using an effective rep model lead you too far astray from good training, assuming you make some reasonable assumptions? No, probably not. But it may also lead some to believe that we have a better grasp on which reps are effective than we do, while simultaneously being useless to track beyond the number of sets and their proximity to failure. But what about time under significant tension? That has to be the solve. Well, unfortunately, it runs into the same issue as the effective reps model. we don't know exactly when significant tension starts and how it fluctuates. In an ideal world, we would quantify the overall stimulus at each portion of every rep through a session and even beyond the session from feeding, stress, basically anything that could affect growth. All we have to do is formulate a stimulus per range of motion curve in accordance with these 18 parameters and compute the integral. Unfortunately, we are so far from being able to do anything like that it ain't even funny. In fact, even many of the leading candidates for prediction have very, very shaky predictive value. Okay, so I'm telling you none of the other ones are very useful. So how do hard sets work and what are the problems there? Well, hard sets are simply the number of sets you do for a muscle group that are taken close to failure, usually within 3 reps of failure. This quantification tool does one thing the others don't. When counting hard sets in studies, everything else is held constant. Exercises used, rest periods, proximity to failure, ideally tempo, and so on. This has shown a pretty useful dose-response relationship. So what's the problem? We solved it. Well, not so fast. The benefit of hard sets as a quantification tool is unfortunately also its downfall. In the real world, everything else is not equal. Will different exercises have a different dose-response relationship? How does proximity to failure change things? What about the position where a lift is hard? Is there more of a recovery burden from sets harder in the more stretched position? While we found a useful tool for comparison in studies, which gives us a good idea of the number of sets we should be doing per muscle group in the gym, it definitely doesn't solve all of our problems. Okay, so now we know why hard sets make sense as a volume quantification tool compared to the others, but still has its issues. In the next video, I'm going to cover how to actually count hard sets per muscle group and some considerations when doing so. As always, I count on you to help my self-esteem, so please like, subscribe, and I'll see you in the next video.